Alright, so in this video we're going to learn a second way to solve systems of equations. Instead of graphing them and seeing where they cross, we're going to learn a mathematical way to get an exact solution without having to draw any pictures. So this is called the substitution method, and first we're going to try to build your understanding for what substitution really is. So substitution in mathematics is just like substitution in other situations in your life. So for example, you've learned about you just know from daily experience what a substitute teacher is. So that's when you replace one teacher with another teacher who is supposed to take their place, or take one out and plug the other in the same spot. Or if you go to the restaurant, you might substitute a veggie patty in place of your hamburger patty. So you're taking one thing out and you're plugging something else in the exact same spot. And the thing that you plug in is different, but supposedly somewhat equivalent. Now that's hard to explain in real-world examples, but you'll see right away in math in this application how it's the same. So to build your understanding in a pretty abstract sense, if you have something like A equals B, so whatever A is and B, they're equal, and you also have A equals C, then what can you conclude about B and C? Well, if A is equal to B and A is equal to C, then it should be reasonable that B and C must be equal to each other. So you can think of this by substituting. So in this A right here, you can plug in something else that's equivalent to it. So from our first equation, we know that A is equal to B. So in place of this A, we can stick in this B, and then we would have B equals C, which is what we have here. So it's a very abstract kind of thing, but the idea is you're plugging one thing in place of another thing that's equivalent to it. Okay, so let's apply this to algebra. So we're going to solve each equation for the same variable and then set them equal to each other. So if you have something like this, say you have, well, let's just be more general. Y equals f1 of x. So y is some function of x. It could be 2x plus 5 or negative 4x minus 3. Any equation like that. And then you also have y equals f2 of x. So a system of equations, remember, is more than one equation with the same variable. So they're both going to have y and x. You've got the first equation is something, second equation is something different. Okay? Then what you can conclude, at the point where these two lines will cross, they'll have the same y value. So this y value and this y value will be the exact same value, and therefore you can substitute this right here into y because y is equal to that. And then you have f1 of x equals f2 of x. And so whatever function you have, if it's like a 2x plus 5 and a 3x minus 4, they have to be equal to each other at that point. And at that point, that's the solution point because it's going to be one point that works in both equations. So let's throw an actual problem on here. So you have something like y equals 2x plus 4 and y equals negative 3x. Let's just do minus 6, something like that. So before, in the previous video, you learned that you can graph these two things and see where they cross. And what you're looking for is one xy coordinate point that works in both of them. So if it's a single point that works in both, the x will be the same in both, and the y will be the same in both. So since I've got these both solved for y, whatever my y value is, that has to equal 2x plus 4. So I can say that the y for the first equation has to equal the y for the second equation, and therefore the first equation, the y value, is 2x plus 4, and the second equation is negative 3x minus 6. And if the two y coordinates are the same, then the overall function here, 2x plus 4, and the overall function here, negative 3x minus 6, those also have to be the same. So you set the two pieces equal to each other, and now we've got an equation here with just one variable. So we can solve it for the x coordinate. I'll subtract 4 from both sides, and I'll add 3x to both sides. Okay, those cancel, and those cancel, leaving me with 5x equals negative 10. Divide by 5, and we get x equals negative 2. So we found the x coordinate, and we can plug this back in to find the y coordinate. Now remember, since the two lines are supposed to cross at this point, it's a single point that works in either equation. So if I plug negative 2 into the first equation, I'll get a certain y value, and if I plug negative 2 into the second equation, I need to get the exact same y value. So what you can do to make sure that you're correct is just plug it into both of them. So we get from the first equation y equals negative 2 times 2 is negative 4 plus 4, which is 0. And from the second equation, y equals negative 3 times negative 2 is 6 minus 6, which is 0. So that tells me my y value is equal to 0. So the solution point is negative 2 comma 0. The x value is negative 2, the y value is 0, and that same individual coordinate point or solution works in both of my equations, so it's therefore a solution to the overall system. So I just did an example. I'm going to skip this to save your time. And there is an alternate way to do this, the idea of substituting. So instead of solving both of the equations so that they have y equals this and y equals that, you only if they come like that, it's great. You just set the entire equation equal to the other entire equation. But if they start off in some other format, there's another way that you can do this, and that is by the way that you think of substitute is where you plug one thing in place of another. And let me show you an example of that. Say one of your equations is 3x plus 2y equals 12, and your other equation is y equals 2x minus 4. Okay, I could, see this one's already solved for y, so that's good. I could solve this one for y, and then I'd have y equals f1 of x and y equals f2 of x, and I could set those two resulting things equal to it. That would be the first version that I showed you. But I don't need to do that because I already know what the y value is equal to. The y value is equal to 2x minus 4. So anytime in this equation I see the y value, I can substitute in place of it whatever it's equal to. In this case, 2x minus 4. So I can substitute in place of this y value the 2x minus 4. So that is going to get plugged in right here. That will give me a rewritten first equation of 3x plus 2. And now in parentheses, because I'm replacing the y with 2x minus 4, I definitely need to put that in parentheses, because it was 2 times whatever the y coordinate is, so it's 2 times this entire piece. So that equals 12. And now, again, I have an equation with just one variable. So the whole goal of this method of substitution is to plug one of the equations into the other equation, and you'll be left with a single equation with just one variable that you're now good at solving. So we'll distribute the 2 in here, and we get 3x plus 4x minus 8 equals 12. We'll add 8 to both sides, and we'll combine those two together. 3x plus 4x is 7x. 8's cancel, and here we have a 20. So we divide both sides by 7, and x equals 20 over 7. Okay. Now, how can I get the y-coordinate? Well, I can, in any case, no matter how you're solving it, as soon as you have the x-coordinate, to get the y value, you plug x back into the equation that you started with, one of these first two equations, and you can get the y-coordinate. So we'll plug this x back in right here, and we get y equals 2 times, in place of x right here, I'm going to plug in whatever I got, which is 20 over 7. Then I subtract 4. So 2 times 20 is 40 over 7 minus, now I need this to get a common denominator to add these together. So 7 will be my denominator, and 4 is equal to 28 over 7. So our final answer then is y equals 40 minus 28 is 12 over 7. So the point where these two cross is 20 over 7, comma 12 over 7. If you wanted to check this to make sure it was right, you could plug this point, this x and y value, into this equation, and it has to work here as well. So remember, whatever your final solution is, it has to work in both of your two starting equations in order to be a solution to the overall system. So with the substitution method, you're getting one of the equations or both of the equations solved for a particular variable, and then you're plugging one of them into the other one. That will eliminate one of your variables, allowing you to then solve for x or y. Once you know x or y, you can plug it back into the original equation to find the other unknown, and then you can check it by making sure it works in both equations.